Good morning, everyone. This is B. Ramarao from Government Polytechnic College, Station Ganpur. Today, our topic Arrhenius acid base theory. Arrhenius acid base theory. This topic belongs to first year diploma student, first semester syllabus, common subject for all diploma students, subject code 104, topic Arrhenius acid base theory. Arrhenius acid base theory. Objectives. After the end of this period, you would be able to know. After end of this period, you would be able to know. Already we discussed in last class what is acid, what are the characters of acids, what is base, what are the characters of bases. Now we discuss different types of theories to explain the nature of acids and bases. The acid and base theories are three types. One is Arrhenius acid base theory, second one Bronsted-Lowry acid base theory, third one Lewis acid base theory. So this theory to explain the nature of acids and bases. Now we discuss first one is Arrhenius theory of acids and bases. This Arrhenius acid and base theory to explain understanding Arrhenius concept of acid, base, salt, neutralization, strength of acids and bases. The concept of acid, base and salt. What is acid? What is base? What is salt? And this theory also explains the nature of acids, bases, salt, neutralization reaction, the strength of acids and bases. Arrhenius concept. This Arrhenius proposed to explain the theory of acids and bases in 1887 according to Arrhenius theory. This theory to explain the nature of acids and bases belongs to aqueous solutions, that is substance completely or incompletely dissociated, it produces H plus or OH minus ions in aqueous solution. This theory to explain Arrhenius in 1887. According to this theory, what is acid? What is acid? Acid, a substance which gives H plus ions when dissolved in water, is called an acid. A substance which gives H plus ions when dissolved in water is called an acid. Acid is a substance that contains hydrogen ions and ionized in aqueous solution to give hydrogen ion is called acid. A substance which gives H plus ions when dissolved in water is called an acid. Acid is a substance that contains hydrogen and ionizes in aqueous solution to give hydrogen ion, that is H plus ions. A substance which gives H plus ions when dissolved in water is called an acid. Acid is a substance that contains hydrogen and ionizes in aqueous solution to give hydrogen ion are called acids. These acids, like example HCl, is dissociated in aqueous solution, it produces H plus ions. HNO3, H2SO4, CH3COH, H3PO4, C2H2O4, H2CO3, these all are acids. It dissociated in aqueous solution, it gives H plus ions. Is called acid. Base. What is base? A substance which gives OH minus ions when dissolved in water is called base. Base is a substance that ionizes in water producing OH minus ions. That means hydroxyl ions produced in aqueous solution is called base. Base is a substance that ionizes in water producing OH minus ions are called bases. A substance which gives OH minus ions when dissolved in water. When dissolved in water is called base. Base is a substance that ionizes in water producing OH minus ions are called bases. Like example bases NaOH, sodium hydroxide, KOH, magnesium hydroxide, MgOH taken twice, ammonium hydroxide, NH4OH, aluminum hydroxide, AlOH taken thrice, so on. These all are bases. Now here any acid Ha is acid. When it is dissolved in water, it dissociated H plus A minus. H plus A minus. This Ha, when it is act as acid, it produces H plus ions in aqueous solution is called acid. Similarly, base, BOH, base. When it is dissociated in aqueous solution, it produces OH minus ions is called base. It is dissociated B plus OH minus. Then Ha, it produces H plus ions is called acid. BOH, it dissociated in water, it produces OH minus ions, then according to Arrhenius, base. Water and here we see HCl. The HCl completely dissolve in water. It produces H plus ions plus Cl minus ions. So these H plus and Cl minus ions, it produces H plus ions in aqueous solution is called acid. Then HCl is act as acid. Similarly, H2SO4 is also dissolve in water. It produces 2H plus SO4 minus 2. It produces H plus ions in water is called acid. HCl and H2SO4 dissolve in water, it produces H plus ions, then these compounds are called acids. Now, NaOH dissolve in water, it form Na plus OH minus ions. This base component dissolved in water, it produces OH minus ions is called Arrhenius base. Arrhenius base. Similarly, ammonium hydroxide. This ammonium hydroxide dissolved in water, it forms NH4 plus OH minus. It produces OH minus ions is called base. These sodium hydroxide, ammonium hydroxide dissolved in water, it produces OH minus ions is called Arrhenius bases. Now, neutralization. What is neutralization? The reaction between an acid and bases is known as neutralization. The reaction between an acid and base is known as neutralization. What is neutralization? The reaction of an acid with an equivalent amount of base to form salt and water. To form salt and water is called neutralization. What is neutralization? The reaction of an acid with an equivalent amount of base to form salt and water is called neutralization. In this reaction, H plus ions of acids combine with OH minus ions of the base and produce undissociated water. H plus OH minus ions to form H2O. So, the reaction between an acid and a base is known as neutralization. Example, NaOH plus HCl acid, NaOH base to form NaCl plus H2. The base of NaOH, the acid of HCl react together to form NaCl salt plus H2O water. The acid and base react together to form salt and water is called Arrhenius neutralization. In this reaction, H plus ions of acids combine with OH minus ions of base and produce undissociated water molecule. In this reaction, the H plus ions of acid combine with OH minus ions of the base and produce undissociated water. Actually, free H plus ions do not exist in water. They combine with solvent molecules, that is hydrated, to form hydronium ion. They combine with solvent molecules, that is hydrated, to form hydronium ion, H3O plus ion. Example, H plus H2O gives H3O plus, is called hydronium ion. This H plus belongs to acid H plus ions. H2O belongs to water molecule. These both combine together to form undissociated hydronium ion. The ionization of acid in aqueous solution should be represented as the ionization of acid in aqueous solution should be represented as HCl plus H2O gives H3O plus Cl minus. H3O plus Cl minus. Limitations of Arrhenius concept. It is applicable only to aqueous solution. It is applicable only aqueous solution. The concept could not explain the properties of all acids and bases. The concept could not explain the properties of all acids and bases. This theory explains only aqueous solution. This theory is applicable to aqueous solution only. Which component completely or partially dissociated in aqueous solution, it produces H plus or OH minus ion, then it is called acid or base. Some compounds does not dissolve in aqueous solution, like benzene, chloroform, carbon tetrachloride. This compound does not dissolve in water. So this type of compounds nature cannot explain according to Arrhenius acid-base theory. The concept could not explain the properties of all acids and bases. This theory failed to explain the acidic nature of some compounds like CO2, SO2, SO3, Na2O, N2O5. These all are acids. These compounds does not contain H plus ions, but these all are act as acids. So according to Arrhenius theory, failed to explain acidic characters of some oxides, carbon oxides, sulfur oxides, nitrogen oxides. This theory failed to explain basic nature of sodium oxide, magnesium oxide, calcium oxide, ammonia. This compound does not contain OH minus ions. So these compounds also act as base. Why it is act as base? So fail to explain about the characters of oxides of sodium, magnesium, calcium. It failed to explain acidic nature of aprotic compounds such as A. SO2, B. NO2, C. CO2, D. P2O5. These oxides all are act as acid. So these compounds acidic character should not explain according to Arrhenius acid-base theory. It failed to explain acidic nature of aprotic compounds like A. Sulfur dioxide, B. Nitrogen oxide, C. CO2, D. P2O5. These compounds nature cannot explain according to Arrhenius acid-base theory. It failed to explain basic nature of A. Ammonia, B. Na2CO3, sodium carbonate. It failed to explain acidic nature of certain salts such as aluminum trichloride. It failed to explain basic nature of ammonia, sodium carbonate. It failed to explain acidic nature of certain salts such as aluminum trichloride, AlCl3. Once again, Arrhenius theory of acid. Arrhenius was a Swedish chemist, but he explained the theory of Arrhenius acid-base theory, put forward a theory of acids in the 1880s. State that an acid is a substance that dissociated in water to form H plus ions. This Arrhenius was a Swedish chemistry, put forward a theory of Arrhenius acid-base theory in the 1880s. What is acid? An acid is a substance that dissociated in water to form H plus ions. Arrhenius theory of acids. For example, when HCl is added to water, HCl added to water. The HCl, when it is added to water to form H plus Cl minus. H plus Cl minus. So, these HCl dissolve in water, it produces H plus ions, is called acid. In general, Ha, when it is dissolved in water, H plus A minus. Substance which is completely or partially dissociated in aqueous solution, it produces H plus or ions are called acids like HCl, H2SO4, HNO3, HCOOH, CH3COH, H2C2O4, HCN, HI, HF, H2CO3. These all are dissolved in water, it produces H plus ions. So these compounds act as acids. In general, any acidic compound dissolved in water, it produces H plus ions. H plus ions. Acids. HCl and HNO3 are monobasic acids as they donate 1 H plus ions. HCl and HNO3 are monobasic acids as they donate 1 H plus ions. Like already we see HCl is dissociated H plus and OH minus ion, Cl minus ions, then only 1 H plus ions dissolve in water. HNO3, it is also dissociated in water, it produces H plus NO3 minus. So these HCl and HNO3 are monobasic acids. So these monobasic acids, they donate only 1 H plus ion in aqueous solution. H2SO4 is a dibasic acid and it donates 2 H plus ions. 2 H plus ions. H2SO4 and H2SO3, H2CO3, these all are dibasic acids. These acids dissolve in water, it produces 2 H plus ions. So these compounds are called dibasic acids. H2SO4 is a dibasic acid as it donates 2 H plus ions. H2SO4 is dissociated to H plus SO4 minus 2. H2SO3 is dissociated to H plus SO3 minus 2. H3PO4 is a tribasic acid and it donates 3 H plus ions. H3PO4 is a tribasic acid as it donates 3 H plus ions. H3PO4 gives 3 H plus PO4 minus 3. So here these tribasic acids of H3PO4 completely dissociated and it produces 3 H plus ions. So these phosphoric acid act as tribasic acids. Tribasic acids. A strong acid is one which dissociated fully in water. Example, HCl, H2SO4, HNO3. These all are strong acids. Which acid completely dissociated in water, it produces more number of H plus ions are called strong acid. What is the strength? The strength of an acid or a base in Arrhenius concept is based on the rate of ionization. And the equilibrium concept is acid and base. As per Arrhenius theory, acids which dissociated to large extent and produce large number of H plus ions in aqueous solution are called strong acids. Strong acids. These strong acids like HCl, H2SO4, HNO3, so on. The HCl, when it is dissolved in water, it produces H plus Cl minus. It produces more number of H plus ions in aqueous solution is called strong acid. Weak acid. A acid which dissociated to a smaller extent and produce less number of H plus ions are called weak acid. A weak acid is one which does not fully dissociate in water. For example, CH3COOH, acetic acid, H2CO3, carbonic acid, H3PO4, phosphoric acid. These all are incomplete dissociated in water. It produces less number of H plus ions are called weak acids. Strong acid completely dissociated, it produces more number of H plus ions are called strong. Which acid partially dissociated in aqueous solution, it produces less number of H plus ions are called weak acid. For example, acetic acid. This acetic acid added to water to form CH3COO minus plus CH3COO minus plus H3O plus. Arrhenius theory of bases. Arrhenius defined a base as a substance that dissociated in water to produce OH minus ions. What is a base? Base is a substance that ionizes in water and producing OH minus ions in aqueous solution is called Arrhenius base. A substance that dissociates in water to produce OH minus ions. For example, when NaOH is added to water to produce OH minus ions. Similarly, reaction NaOH gives Na plus OH minus ions. In general, XOH gives X plus OH minus. So, which substance completely or partially dissociated in aqueous solution, it produces OH minus ions are called bases. A strong base, the base which dissociated completely in aqueous solution and produce more number of OH minus ions are called strong base. A base which dissociated in aqueous solution and produce more number of OH minus ions are called strong base. Like example, sodium hydroxide, potassium hydroxide, lithium hydroxide, so on. These sodium hydroxide NaOH dissociated in aqueous solution to form Na plus OH minus ions. Which base completely dissociated and produce more number of OH minus ions are called strong base. Weak base. The base which dissociated in aqueous solution and produce less number of OH minus ions are called weak base. A weak base is one which does not fully dissociate in water. It produces less number of OH minus ions in aqueous solution are called weak base, like ammonium hydroxide, magnesium hydroxide. These ammonium hydroxide and magnesium hydroxide incomplete dissociated in aqueous solution, it produces less number of OH minus ions. So these compounds are called weak bases. According to Arrhenius theory, Ha gives H plus A minus. XOH gives X plus OH minus ions. When it is acid and base both combined together, these Ha acid, XOH base to form A NaX plus H2O. These HA acid XOH base react together to form AX is salt H2O water. According to Arrhenius theory, the acid and base react together to form salt and water is called Arrhenius neutralization. According to Arrhenius theory, the acid and base react together to form salt and water is called neutralization. Limitations of Arrhenius theory. The acid and base must be in aqueous solution. It prevents the uses of other solvent like benzene. The substance acid and base in aqueous solution only. This prevents the uses of other solvents like benzene, carbon tetrachloride, chloroform, so on. Not all acid and base reactions are in solution. For example, ammonia gas and hydrogen chloride gas produces ammonium chloride. Not all acid and base reactions are in solution. For example, ammonia gas and hydrogen chloride gas react together to form ammonium chloride. Ammonium chloride. According to Arrhenius, the salt produced should not be acidic or basic. This is not always the case. For example, in the above reaction, ammonium chloride is slightly acid. Ammonium chloride is slightly acidic. So these are our limitations of Arrhenius acid-base theory. What are the limitations? According to this theory, it explains only aqueous solution. Non-aqueous compounds nature cannot explain according to Arrhenius theory. This theory failed to explain acidic characters of CO2, SO2, SO3, N2O5, so on. It failed to explain basic characters of ammonia, calcium oxide, sodium oxide, magnesium oxide, so on. The hydration of hydrogen ion in water was not explained by this theory. So, this theory should explain only aqueous solution. That means compound completely or partially dissolve in water and produce H plus R and OH minus ions in aqueous solution, then it is act as acid or base. This theory prevents the uses of other solvents like benzene, carbon tetrachloride, chloroform, so on. This theory not all acid-base reactions in solution. For example, some gas components also react together to form salt and water like ammonia gas react with hydrogen chloride to form ammonium chloride. According to Arrhenius theory, the salt produced should not be acidic or basic. This is not always the case of example in above reaction. That is formation of ammonium chloride. Summary. Acid, it gives H plus ions in aqueous solution. Substance completely or partially dissociated in aqueous solution and produce H plus ions are called acids like HCl, H2SO4, HNO3, CH3COH, H2CO3. These all are acidic. These dissolve in aqueous solution and produce H plus ions. So these compounds all are acids. Base gives OH minus ions in aqueous solution. The substance completely or partially dissociated in aqueous solution and gives OH minus ions are called base, like sodium hydroxide, magnesium hydroxide, calcium hydroxide, ammonium hydroxide. These all are bases. Acid and base combine together to form salt and water. The reaction between acid and base to form salt and water is called neutralization reaction. The acid and base react together to form salt and water is called neutralization, like HCl acid, NaOH base, HCl hydrochloric acid plus NaOH, sodium hydroxide gives NaCl plus H2. So this reaction is called neutralization reaction. Quiz questions. First one, what is Arrhenius acid? What is Arrhenius acid? Which is act as acid belong these compounds? A. CO2 carbon dioxide, B. SO2 sulfur dioxide, C. SO3 sulfur trioxide, D. HCl. According to Arrhenius theory, the substance dissociated in aqueous solution and gives H plus ions are called acid. Given below options A. SO2, B. SO2, C. SO3, D. HCl. Given options CO2, SO2, SO3. This compound does not present H plus ions. It does not give H plus ions in aqueous solution, but here HCl, when it is dissolved in water, it produces H plus ions. So Arrhenius acid is HCl. Answer D. Next question. Which is Arrhenius base? Which is Arrhenius base? A. Ammonia, B. Calcium oxide, C. Sodium hydroxide, D. HCl. According to Arrhenius base, substance completely or partially dissociated in aqueous solution and produce hydroxyl ions are called Arrhenius base. Here ammonia, it dissolved in water, does not produce OH minus ions. Calcium oxide, it dissolved in water and cannot produce OH minus ions. HCl, it produces H plus ions in aqueous solution. Here sodium hydroxide, only it produces OH minus ions in aqueous solution is called Arrhenius base. So once again, which is Arrhenius base? Options A. Ammonia, B. Calcium oxide, C. Sodium hydroxide, D. HCl. These ammonia, calcium oxide, HCl does not produce OH minus ions in aqueous solution. According to Arrhenius theory, sodium hydroxide, it produces OH minus ions is called base. Answer C. NaOH. Arrhenius failed to explain the acidic nature of A. CO2, B. SO2, C. SO3, D. Above all. Arrhenius failed to explain the acidic nature of oxides of carbon, sulfur and nitrogen. These all are acids, but according to Arrhenius cannot explain above these compounds acidic nature. So answer All the above. Frequently asked question about this topic. State and explain Arrhenius theory of acid and base briefly. 2. Explain neutralization. Explain neutralization. Thank you once again. Thank you.